Hello. Hello.
Yes, sir.
Yes, good evening. Oh, and very sorry for the late start of the program. And let me also apologize for the change in time. Per our initial plan, this program was to be scheduled from 6 p.m. to 8 p.m. But unfortunately, we having to do an adjustment because some of our facilitators or lecturers will not be able to make it during that period. So please pardon us. For some of the lectures, we're going to have them from 4 p.m. to 6 p.m. and then the rest will be at the stated time, 6 p.m. to 8 p.m. We are delighted to have all of you join this program. We anticipate more of your colleagues to join. So far, I think the number that has registered is more than what the number that has joined the program now. We hope that as the lecture goes on, others will follow. So we welcome all of you. This is the second time we are organizing this program. The first time was for during the supplementary exams a couple of months ago, and thank God it was very, very successful. If you ask those who joined the program, they'll tell you about their experience. So we hope to consolidate that achievement this time around. Our objective is to help all of us to make a very successful attempt at this exam. We don't want you to go through and then not be successful. And the key to this is for us to pay particular attention to our facilitators, take notes whilst the lectures are going on, take few notes. It will be helpful. And ask questions as and when you deem fit to ask a question. You can stop the lecture anytime and then ask a question. If you have any other issues, you may want to contact us. You can do that behind the scenes possibly, or you can even contact the lecturer privately. So without much talk, I once again welcome you to this program, and we hope to have a very successful exam prep. So I'll hand you over to our lecturer for today, MLS Thomas, Chief MLS Consultant, Chief MLS Thomas Kwabena Jampoma. He's going to take us for microbiology today, and then we'll continue with it tomorrow. Grandpa, we popularly call him Grandpa. Those of you who know him, Grandpa. So Grandpa, I hand over your student to you. Thank you.
All right. Thank you very much, fellow. And I'm also happy to be part of this program. It is my hope that all who go through this program will find it beneficial, not just for examination purposes, but also to fill in certain gaps within the period of our study in school and even during internship. There are a lot of things that probably we do where the science behind that concept may be missing. This is what we are here to support you with. We are not here to provide questions, but we are here to provide you a guide to answering any possible question that might be thrown at you. That is our focus. So if you think that we are going to be discussing licentiate questions, I'm sorry, you may be at the wrong place. But if you want to learn beyond exams to the extent that, yes, once you go through this, I have no doubt in my mind that a lot of the things that you're discussing will expose you to some of the potential questions. And also, no matter how the question will be tricked, you will be able to solve it. And beyond that, you also learn a lot of things that will support you in your practice, because even after examination and you have passed, you need to show competency at your practice or during your practice. And some of those competencies is based on the quality of knowledge that you have. And so, like I said, sorry, give me a minute. Hello. Yes, sir.
But the song is nice, so.
So sorry for that. I'm still at work side, so you can expect some of these interruptions occasionally. Right. We want you to pay attention, and like the director said, you may want to put down some notes, and there is not going to be much to be shared by way of slides. A lot of it is going to be, so this is actually in the form of tutorials. If it's tutorials, then it's going to be some sort of practical tuition of a sort. So don't expect that we are going to discuss exam questions. I've said this and I want to repeat. We are not going to discuss exam questions, but we want you to learn. And having gone through this, you realize that the exams become like, I don't know, it becomes like a bonus something for you, because there's virtually nothing that will come in the exams that you may not have heard before. So that is my preliminary remarks. On that note, my other appeal is what the facilitator told you earlier, that because of some other engagements, it may be almost impossible for me to make myself available for you at the advertised time, that is 6 to 8. It's supposed to be 6 to 8. Yes, I'm sorry, I may not be able to meet that time schedule. And so I'll plead with you to bear with me, and that most of the time, depending on my availability, I may request that we meet at certain times which are beyond the advertised time. And whenever it happens, so I'll try to give at least prior information, and then so that you also adjust yourself as much as possible. So that is my plea. All right. Whenever we fix time and it's not convenient for you, I think sometimes we can also discuss, and then all of us can make compromises on the platform. If you, for example, you have to meet this 4 to 6, a majority of you think that it's not possible, you can discuss on the platform and then agree on a time that will be convenient for me, and of course also for you. But for today, because it's the start, we needed to do something at all costs, and engage ourselves further with the timing as we move along. So, my dear ladies and gentlemen, it's my pleasure once again to be your facilitator for microbiology. And you know, microbiology entails bacteriology, parasitology, mycology, and some element of virology or serology. But for purposes of preparing for exams, a chunk of it will be in bacteriology. So if, let's say, we give bacteriology 60%, then parasitology may take also, let's say, 30, say, let me say 20%. The rest will take, say, 10% of a source. So if you're able to handle your bacteriology and parasitology very well, it means that you are likely to pass. How do you get me? That is how the exam is skewed. When it comes to microbiology, it's about 60% bacteriology, about 20% pathology, and 10% of the rest. So on that note, you also try to move within that direction so that you find yourself comfortable handling the exams questions. So, and today's meeting is a combo type from the organizers. Combo means a combination. And so you have people who are preparing for diploma, you have people preparing for MLS. I know for purposes of the examination, the MLS and MLSD write the same exams. The MLSD write different exams. MLS also write different exams. But in our discussion, there are certain things that are so basic. So, for example, as we start today's combo for all, it means that we cannot just start from a certain level to the disadvantage of the diplomates. So we start from the diploma level basics, and then we build on from there. At a point will come where you will gear more into the MLSD stuff. So also understand from that angle. So today's lecture is going to be very, very, very basic. And you may think that it's not even necessary for the MLS and MLSD people, but you see that if the foundation is strong, it becomes easier to comprehend or to appreciate the more complex scientific concepts. So don't think that, oh, this thing is so basic. Yes, they are very basic, but all of us will need them at one point or the other. Like I said, we are not preparing you just for examination, but also to support your practice and to improve your competency levels. All right. So we start. And how are we starting? We are starting from something which is so basic. And so you put highlights on some basics in microbiology. So I'm hoping that you are seeing my slide very well. Are you seeing my slide?
Yes, sir.
Okay, good. So on the right, you see a picture of saline solution. In fact, in 2018, I had the privilege of going to a certain hospital in Côte d'Ivoire. I was supposed to be a consultant to help them to set up a microbiology unit. And you're Samuel, can you mute yourself, please? Thank you. I had the privilege of going to Côte d'Ivoire as a consultant to help set up a microbiology laboratory for one of the hospitals. When I went there, I observed that they are using saline solution. And because they felt that it's saline, that was the source of saline that they have been using for some. In fact, it wasn't a new hospital. It was an existing hospital, except that they didn't have a established microbiology session. And I was there to support them to start it. But this saline that they've been using for their stools and stuff like that. And so when you look on the bottle, you see sodium chloride 0.45%. All right, and then there's a pH there and the 500 ml. This is a commercially prepared saline solution. So when I interrogated, it is just because they said it's saline and saline is saline. I have to draw their mind to the point that the saline we use in the lab don't have a concentration of 0.45. So, but any salt solution is saline, whether it has a concentration of 0.001 or 0.1 or 1 or whatever, any salt solution is saline. So it is not the concentration that makes it saline. Okay, the fact that it is salt solution alone is saline. Okay. What we use in the lab is normal saline. Okay, and so if you say saline, you haven't said anything. You have only said that it is a salt solution. But if you say normal saline, you are talking about a salt solution of a certain concentration. So that is the point. All right. So what is normal saline? It is that salt solution whose concentration is 0.85%. Take note of that. 0.85%. And this is often approximated to 0.9. No, 0.85 can easily be approximated to 0.9. So if you have a salt solution whose concentration is 0.9%, it is not just saline, it is normal saline. As soon as you say normal, you are referring to a certain specific concentration, and that is 0.9. So for scientific purposes, now you see of the normal. So you call it hyperthermia. Okay, and also dehydrated. And the clinicians want to manage. Normal sodium and chloride in the system. So therefore, we also call normal saline isotonic. The word iso means the same. Tonic means tonicity, that is concentration. So they have the same concentration. So if the person has hypernatremia with dehydration, and you will say want to give, you rehydrate, and you give a full strength normal saline, then you are going to, the system is going to rather be choked with more extra sodium, okay? And so they prepare this half strength so that as it's infused into the patient, the hyper solution is not going to now, it's like, why am I in children something like that. So you are giving a half strength solution so that the patient which already has hypernatremia will now, the volume of fluid you are giving in will now feed into the hyper state, so that at a point there's going to be that kind of balance. So yes, we have half strength normal saline. It is not supposed to be used in the lab. It's supposed to be used for clinical purposes. And the fact that they have written saline solution doesn't make it saline for anybody to use. I hope that I'm making some point. This is a practical thing I saw in La Côte d'Ivoire. And up to now, normally I try to bring people up to speed with the fact that saline solution, if you say saline solution, that doesn't mean anything. But the one that is used in the lab is normal saline. The concentration here is 0.9%. Specifically, it is 0.85%, but it can be rounded up to 0.9. So for purposes of examination, if they will ask you a question at all. They want to, let's say, if you want to prepare 2 liter normal saline in your lab, how are you going to do it? Then they can bring in a series of that kind of what they call answers. You see, so if you are going to prepare 0.85, and let me even make it 0.9%, then it means that we have 0.9 grams in 100 ml. I hope you are following me, and you are making some small notes on your own. So if it is 0.9 grams in 100 ml, then for 1 liter, your 100 ml should be multiplied by 10. Because 0.9% means 0.9 grams in 100 ml. So for 1 liter, you have to multiply the 100 by 10 to give you 1,000 ml, which will now end up to give you 1 liter. Because you have multiplied the water component by 10, you also have to multiply the salt component, which is 0.9, by also 10. So the salt component is now going to be 9 grams instead of 0.9. I hope you are following me. So you get 9 grams in 1 liter. So if they ask to prepare 2 liters, then the 1 liter here should also be multiplied by 2 again to give you 2 liters. And then you multiply the 9 grams also by 2 to give you 18 grams. So it means that if you weigh 18 grams of the salt and dissolve in 2 liters of water, you will still get your normal saline. So that is how, for examination purposes and for that matter at the diploma level, that's how we're going to ask questions. That how will we prepare, or which of the following statements describes the way to prepare, let's say, a 2 liter normal saline in your lab. Okay, so just know that a normal saline is made up of 0.9%. And 0.9% means 0.9 grams in 100 ml. Okay, so 0.9, so you write that one as your baseline statement, 0.9 grams, then dash 100 ml. And then they are talking in liters. So for liter, the 100 ml should be converted to 1 liter. How can 100 ml become 1 liter? Then it means that if you multiply the 100 by 10, you are going to get 1,000 ml. And that 1,000 ml is equivalent to 1 liter. So you are done with the liquid side. Then you come to the solid side. Because you have multiplied the 100 by 10 to give you the 1 liter, you must also multiply the 0.9 grams by 10 to give you 9 grams. Okay, so you have also satisfied. So assuming that the question was for 1 liter, then it means that you weigh 9 grams, okay, of the salt in 1 liter and you are done. If they make it 2 liters, and you go ahead and then also multiply by 2. If they make it 5 liters, I mean, you understand the principle. If they make it, how will you prepare 5 liters of normal saline? Then it means that your 9 grams in 1 liter, now you are multiplying the 1 liter by 5 to give you 5 liters. Then you come to the left side, and then you multiply the 9 grams also by 5. You are going to get 45 grams. So 45 grams in the 5 liters will still give you your 5 liters normal saline, which is 0.9%. So just understand that principle and you're okay with that. So this slide is just exposing you to the types of saline that can be used. As far as I know, if you have the half normal saline, which is 0.45 as you have in this picture, then it will become hypotonic because the 0.9 is isotonic. That's the concentration of the cells in the body. Okay, now, so this concentration is equal to that of the body. So that's the word iso. Anything below 0.9 becomes hypo. So if you have half normal saline, half strength normal saline, which is 0.45, then automatically is going to be hypotonic, below the tonicity. So that's hypotonic. Once it's hypotonic, I'm saying that it can have a usage, clinical usage in patient management. For the lab, probably you may not need it so much. Now, you can also have 5% saline. You can't say 5% normal saline because normal saline is 0.9%. So you can't say 5% is way above the normal saline. So you can't go and say 5% normal saline. You've said that any solution made up of water and salt is saline. So when we are saying 5% saline, it means that it is 5 grams in 100 mils. Percent means 100 mils. Okay, so 5% would mean 5 grams in 100 mils of water. Of course, they say water. This is definitely going to be hypertonic because the isotonic is 0.9%. And it is the same thing, which is the normal saline. So any concentration higher than the 0.9 becomes higher tonic. So 5% saline is necessarily hypertonic. I hope you get my point. Now, what is the use of 5% saline? Of course, it also has clinical use in patient management, and especially if somebody also have hyponatremia. You know that the first one, we said that when the patient is hypernatremic. If the patient is hypernatremic, you cannot give a normal saline. You have to give hypotonic saline, which is probably half strength, half normal saline. In the reverse is that if the patient also has hyponatremia, then you have to give the patient more of the sodium, and therefore giving normal saline may not be appropriate. You have to give hypertonic. So that is that for clinical management of the patient. But in the lab, please listen to me here well and well. 5% saline can be used as a control for urine distich specific gravity. The urine distich specific gravity. Normally, if you have a new urine distich and you want to control it, you want to see whether it is working, one of the parameters to target will be your specific gravity component, the specific gravity component. Right. Normally, you may want to get some diabetic patient or somebody with nephrotic syndrome. Then you take a sample to see whether the protein will show or this thing. Yes, you can do that. In ideally, you are supposed to have what you call UQC. UQC, urine quality control specimens. As you have with hematology, you may have control blood samples for full blood count. You are also supposed to have controlled urine quality control samples to test for the dipstick. Unfortunately, we don't have it. Suppliers don't bring them, and we also don't ask for it. So what I recommend for all of us is not to use the sugar or the protein. They can easily pass. You target the specific gravity, because the specific gravity is also one thing which normally the manufacturers think that people don't pay attention to. So you target the specific gravity. And specific gravity, you do 3 things. The still water, normal saline, and 5% saline. I hope you are paying attention. You want to test the quality of a dipstick. Target the specific gravity component, and then do 3 things. Take the seawater, take normal saline, and then take 5% saline. So you can easily prepare 5% saline in your lab. 5% saline means 5 grams of the sodium chloride in 100 ml of the seawater. That's your 5% saline. Okay, so then you can keep it. Now, when you take the dipstick, you look at the pad, the section for the specific gravity. And then, so you take 3 strips. So the first strip, you just put the seawater there. You don't have to dip it in because you're only testing for the specific gravity. All right, so just take the a pipette, take some of the seawater, and then wet the specific gravity portion. Now, specific gravity of water will necessarily have to give you 1.000. Okay, if it doesn't give you, it means that there's a problem with the specific gravity part, that section. Now, the normal saline. So we talked about the seawater. The seawater should give you specific gravity of 1.000. Normal saline should give you 1.005. 1.005. That is the normal saline. 5% saline should give you 1.030. These are standard references. And so once the specific gravity pass for all these ones, we can be sure that the strip is of good quality. If the specific gravity fails, as per this test, you can reject the whole strip, because either all or none. Let's say either all or none. You see the strip may have about 10 parameters. All the 10 parameters should pass. If one of them is failing, the whole thing has failed. That's why I'm saying it's either all or none. So you target because the specific gravity, the manufacturers usually don't pay attention there. They don't think that they don't even think that it's necessary. So they can have. So that's also an area you and I can target, and then use it as a check on the quality of the urine strip. All right. So what I've said here is that we are not just going to take you through questions, no. But so, for example, any question that will come around saline, I'm sure that you'll be able to deal with it. And normally it will be based on, especially for at the diploma level, how will you prepare, let's say 2 liters or 5 liters of normal saline, okay? Right. And we move on. If there is any question anybody wants to ask, please, and we have time for you. You can draw us back. All right. Fortunately for this batch, this program was started earlier in the year for those who are preparing for the visit, and it was so much in a rush. Thank God they all were able to pass. Now I think we have close to about 2 months for this sort of sessions. It means that we can also take our time, and of course we are not going to do everything, but whatever we do, you also understand it very well. First and foremost, to be able to pass any exams questions, and then also to make it part of your practice to improve on your skill and competencies. That is my hope, and I believe that all of us will listen. Right. So we are looking at some of the small things, highlights on some of the small things that we overlook in the lab. Right. So we're done with the saline. That's one thing too that sometimes they ask questions about, and I want to, and these questions usually will normally be targeted at the diplomates. When I say diplomates, it's like the lower cadre, okay, because they think that this one, the MLS and MLSD, it may be too high, sorry, too low for you. And sometimes I tell the people that they think that it is, you know it already. If they know that you don't know, they begin to ask questions on that. That's just by the way. So in microbiology, one of the regular things that we use in the lab is the inoculating loops. Inoculating loops, which we use for the streaking. When, for purposes of streaking, I mean, the loop that you use, you then need to know the size of the loop, okay, for purposes of streaking. A friend said that there was somebody who had fire in the house and was looking for the still water to quench the flame. And then another person said, Master, we don't need the still water to quench the flame. So you don't need any quality water to put on fire. So that's just by the way. So for purposes of streaking, you don't need a known size loop. Any loop at all can be used, right? So, and we call those ones non-calibrated loops. Non-calibrated loops. It also doesn't mean that if indeed in the house I have the same water and there's fire, and that is what I lay my hands on, that doesn't mean that I couldn't have used that same water. So coming back, that doesn't mean that if I want to streak and there's a calibrated loop there, I don't have to use it. No, you can use it. But what I'm saying is that for streaking, you don't necessarily need a calibrated. In fact, you don't need a calibrated loop. Any loop, all loop be loop. Any loop can be used for the streaking. However, if you have to do with samples, especially body fluids, and body fluids here will include urine, where at the end of the day, you calculate the colonies that is growing, then it means that you will need to know the volume of the specimen that you are using as your inoculum. When the inoculum is a portion of the sample you have collected to do your streaking. Okay, that's the inoculum. So, for example, these days, nobody does manual WBC count. I'm talking about hematology. Nobody does manual WBC count. It's all automated. You just push it into the automated machine, and then there it goes. But previously, we used to do manual WBC count, and it will take 20 microliters of blood sample. At the end of the day, the WBC is reported as something, let's say 3.5 times 10 to the power 9 per liter. I hope you are following my argument. You will report it as, let's say 3.5 or 1.2 or so times 10 to the power 9 per liter. Times 10 to the power 9 per liter means that that is the numbers of WBCs in 1 liter of blood sample. So 3.5 times 10 to the power 9 per liter. That means that is the quantum of white cells in 1 liter. But that doesn't mean that you need 1 liter of the blood as your sample to work with. It doesn't have to be that way. All right. It also doesn't mean that you can take any sample, any volume of sample at all without even knowing how much it is and then do the calculation. It also doesn't work out that way. What it means is that you need a small amount of blood sample, but that small amount should be known so that, for example, you know that I'm using 20 microliters of blood. These 20 microliters of blood gave me, let's say, 300 white blood cells. Then from there, you can extrapolate and do a calculation and say that, oh, if 20 microliters of blood sample gave me 300 white blood cells, Then for 1 liter, I'll do my calculation and know that, oh, then for 1 liter, I'm going to get, let's say 2.3 times 10 to the power 9 per liter. That's how it is. Right. So coming back to where we are now, saying that for urine, you always want to know the number of colonies that is growing per mil of urine. Number of colonies that are growing per mil of urine. Now, it doesn't mean that you need 1 mil of urine to do the culture. It doesn't mean that. It means that you can take any small amount of urine, but that small amount of urine that you pick, you should know the volume. Now, having known the volume, at the end of the day, you can now calculate the number of colonies that are growing from that small volume of urine that you pick, extrapolate to now get the number of colonies in 1 mil of urine. I hope that I'm making some sense. All right, so for the purpose of that, you have calibrated loops. These days, we have what do you call it? Plastic disposable loops. Those plastic disposable loops come in standardized. Standardized means that they have been calibrated. So they will tell you that this is a 1 microliter loop. This is a 10 microliter loop. Okay. So once you know that, oh, this is a loop, normally they give them colors. You have blue colors, white colors, and then yellow colors. Normally the white color is 1 microliter. The blue or yellow will normally be 10 microliters. All right, so they come in calibrated like that one. Now, so if it is a plastic disposable calibrated loops, the value will be written on it, so you don't have a problem. Now, most of our labs don't also have the benefit of disposable plastic loops. They don't have that benefit. So we are only using wires. And remember, those wires have some properties. You can't use any wire, bend the end and make it a loop and decide to use it as an inoculating loop. Now, the kinds of wires that we use for inoculation, for in bacteriology, we have platinum, we have chrome, we have tungsten, we have nickel. I hope you are writing this. Now, the kinds or types of metals or wires that are used in microbiology as inoculating loops. You can use platinum, you can use chrome, you can use tungsten, you can use nickel, and you can use an alloy of nickel and chrome. An alloy of nickel and chrome is called nichrome. Okay, so these days, majority of the wires are made of nichrome. But if you have platinum, any of those that I've mentioned before, you can use it. All right, but nichrome is now more preferable. It is so because you see that if you have one loop, you need to be re-sterilizing almost frequently over and over again. It has the capacity, nichrome has the capacity to withstand that prolonged usage. All right, the rest, if you expose them to the fire on and off, within a short time, they just go off. But one thing too is common about all these tungsten, chrome, nickel, nichrome, what have you. One thing that is also unique about them and for which purpose they are used in bacteriology is the fact that they pick up heat fast and release the heat also very fast. Okay, all right. they pick up the heat fast. So their coefficient of heat, what about the thermodynamics people will say it. So if you put them in, let's say, a Bunsen flame, within a matter of seconds, you see that they become red hot. If you use copper and put the copper in the Bunsen flame, it will have to take several minutes before it becomes red hot. That is not the type of metal that can be used in bacteriology. You want a metal that once you're exposed to heat, it becomes red hot as fast within seconds. And once you remove it from the heat, within a matter of seconds too, it loses all the heat. So that is, if you want to choose a metal for bacteriology, that is the key characteristics that you have to look out for. Those metals that have capacity to pick up heat fast and then lose the heat also very fast. So that's why you cannot use ordinary metal like copper, steel, and what have you, to do the inoculating loops. All right. So I've said that. Now, when you have a loop, sometimes commercially prepared, it comes to you and you need to calibrate it. Okay, if you want to use for normal streaking, like I've said, calibrate it. So you can use Therefore, you need to do a calibration. But the standard correlation is that if you have a loop and the internal diameter is 4 millimeters, if you have a loop with an internal diameter okay, this one you have to know it. And this is also a very that's an inoculating wire loop of internal diameter of, let's say, 4 millimeters would deliver. When I say would deliver, it means that they want it, because if what it picks is what it is going to deliver. So the terminology is either it will pick up or it will deliver. It is the same thing. So if they don't use the word picks up and they use the word deliver, you should know that you only deliver what you have picked up. And the loop, from meanwhile, you use 10 macro convert to microliters, you multiply by 1,000. These things are very, very, very basic and you have to know them. So 10 microliters, you want to convert to mils, you have to divide the 10 by 1,000, and it's going to give you 0.01. I'm sure this one everybody knows. The easier way is that if you write 10, it is assumed that there's a point after the 10, after the 0, 1, 0. So there's a point after the 0. And this point can move forward or backwards depending on whether you are dividing or multiplying. So if you are dividing, that point will have to move backwards according to a number of zeros that you are dividing. So if let's say I'm dividing by 10, then my point, which is at after the 0, will move backwards by 1. Okay, so if I have 10 divided by 10, then my answer is 1, because the point will have now come between the 1 and then a 0, and then my result is 1.0, which is 1. If I have to divide by 1,000, I'm dividing 10 by 1,000. My point is after the 0, 10, that is 1, 0. So my point is after the 0. I'm dividing by 1,000. So my point is moving backwards 3 times, because 1,000 has 3 zeros. So I move backwards 3 times. So 1, 2. So my second point will come, the 2 will come now after the 1, 0, after the 1. But I'm moving 3 backwards. So I'll move another backwards. When I move another backwards, there's now a space here. So I fill that space with 0. So now I wish that it was a blackboard, then you could see. But these ones are so basic. In fact, they're very, very elementary. Now, even the class 3 people, class 4 people, they know this. That if you are multiplying, divide the number by let's say 1,000, you are moving your point. You are moving the point backwards by 3. If you are multiplying by 1,000, moving forward by 3. So that's how come 10 microliters becomes 0.01 mils. All right. So if 0.01 mils is giving me, let's say, 10 colonies, or let's say 20, now my example here is 70 colonies, giving me 70 colonies, then what would be 1 mil? So 1 mil will mean that now I have 0.01 here. How does it become 1? How does the 0.01 become 1 mil? In this one, I want somebody to tell me. I have 0.01 mil. How does it become 1 mil? Anybody to help us with an answer? I have 0.01 mil. I want it to become 1 mil. Yes, Sammy?
Yeah.
Yes, yes.
Yes, sir.
Yes,
So
sir.
when it's 0.01 mil and you want 1 mil, it means that you have to move it 2 times.
Yes, sir. Yes, sir. And moving it 2 times becomes what? Means
1.
what? Yes, we get the 1. Means what? Means that you are multiplying by 100.
100, yes.
So yes, you are moving it forward by 2 times. So moving it forward by 2 times means that you are multiplying by 100. Right.
Yes, sir.
So
Yes, sir.
when I have multiplied that by 100, it means that by 70 colonies, you also be multiplied by what? By 100. As simple as that. Very, very, very simple. Very, very, very simple. So then my 70 colonies now have become 70, sorry, 70 multiplied by 100 will make 7,000. Then you bring CFU. CFU means colony forming unit per mil. That's all. That's all. Very simple. This one too, I'm aware that it's also one of the, sometimes it's one of the way they ask the diplomats, that if you use, for example, if you use a 1 microliter loop, remember, if you use a 1 microliter loop, then the mils component will be what? Yes, you can tell me. If you use a 1 microliter loop, the mils component will be what? I'm using a 1 microliter loop. The mils component will be what? Who can tell me? We just said it. Yes, anybody who wants to? You can unmute yourself and tell me. or raise your hand in a chat and then.
0.001.
That's all, 0.001. 0.001. So if it is 0.001, 0.001, and I had, let's say, 20 colonies from that plate, then what will be the colony forming unit per mil? It means that my 0.1, I must make sure that my 0.001 now becomes 1 mil. How does it become 1 mil? I'll multiply by 1,000. Okay, when I multiply by 1,000, I'm going to get 1 mil there. Then the 20 colonies should also be multiplied by 1,000. So I'm going to get 20,000 colony forming unit. So this is, if you understand some of these things, like I said, normally they don't ask the MLS and MLS this question, but they ask the diplomats that you use a 1 liter, sorry, a 1 microliter loop for urine and got, let's say, 30 colonies. What is the colony count per mil? You should be able to do this. So once they give you a microliters, convert that microliters to mils, okay? And to convert microliter to mils, divide by 1,000, okay? Once you convert, you divide by 1,000. If it's 10 microliters, it will become 0.01. If you use a 1 microliter loop, it will become 0.001 mil. So you get that point. And then the colonies they have given you is also there. They want it in per mil, but you have gotten 0.01 mil. So you also have to convert that 0.01 mil also to mils. You are going to multiply by, let's say, 100. As soon as you multiply that by 100, then you multiply the colony size also by 100. As simple as that. I'm sure that this one should not beat anybody. I've said it that normally, as far as I know, they won't ask MLS or MLSD this question. But it's also important, like I've said over and over again, we are not just preparing ourselves for examination, but we are also educating ourselves on practicality of some of the things that happens in the lab. All right. So for the urine, normally any colony count which is not up to 100,000 colony forming unit per mil is deemed to be not significant. It's deemed to be not significant. It becomes significant once so the threshold or the cutoff is 10 to the power 5. Okay, this one too you must know. So, but sometimes the department or the laboratory can make certain decisions based on a lot of factors. They know that it should be 10 to the power 5, and for that matter, 100,000 colonies per mil of colony forming unit. But if it is 10 to the power 3, for example, and the patient has a lot of, let's say, parcels, and the patient is also, let's say, a child, for example, you see that, yes, the bacterial load is not too high. As per the standard, it should be 10 to the power 5. This one is 10 to the power 3. But based on the fact that it's a child and also has a lot of parcels, mean that the patient is very sick. And for that matter, you can lower the significant bacteria threshold to as low as 10 to the power 3, and then work on it. I hope I'm making some point. So that's in practicality, that is how. So if somebody asks you under what circumstance will you, let's say, lower the threshold for colony forming unit for significant bacteria. It also includes somebody who is also immunocompromised. If the patient is immunocompromised, I mean, the significant bacteria threshold can also come down to, if let's 10 to the power 4, 10 to the power 3, depending on what the lab will say. So yes, the 10 to the power 5 is like a threshold for normal immunocompetent individuals, but it can be adjusted lower depending on factors that we have described, either the age or the immune status of that individual, and so forth and so on. All right. Okay. Any question? All right. So I'm just highlighting on some few things that we see in the labs, for which sometimes they ask questions about, especially for the lower KEDA. When I say lower KEDA, excuse my language, I'm not impugning the fact that diploma is so low, but you know that we have 3 KEDAs now, and so therefore the diploma has become the lower KEDA now. As far as I know, the MLS, the MLA, I'm sure is no longer recognized. I'm not sure they set questions for them now. Even if they set questions for them, I'm sure this platform is not making room for a laboratory assistant. That's the certificate level. And so as far as this program is concerned, our lower KEDA become the diploma. So pardon me if occasionally I use the word lower KEDA. Right, so these are some questions that they ask and they expect you to know. For example, the Petri dishes that we use in microbiology. Petri dishes, you have various sizes, okay? And sometimes people take it for granted and they don't even know, yes, they know that is the Petri dish that we use, but they don't care what size it is. So the traditional size, let me see, yeah, this one, I hope you can see it. This one, we call the standard Petri dish. All right, so let me see if I can. Yes, this one. This is the conventional or traditional Petri dish that we use. So we call it standard Petri dish. It has a dimension of 90 by 15. 90 means a diameter of 90 millimeters. That's the internal diameter there. You know that it has a lid and then the base. Okay, the base, you're talking about the base. Now the base has a diameter of 90 millimeters. It has a height of 50 millimeters. There are various types or sizes of the Petri dish. There are some as small as 30 millimeters. Normally, it is the size of the base which will change, but normally, the height will usually be the same, 50 millimeters. So even if it is 30 millimeters for the base, the height will still be 15. You can have some as much as 150 millimeters, which is very big, 150 millimeter plate. Now, still the height will still be 15 millimeters. So the diameter is what we're talking about. And it is important to know the diameter because we use it in calculation of how much broth, and for that matter, how much of agar should you pour into a plate. For example, if you want to prepare Muller-Hinton agar for your sensitivity test, you know, in preparing Muller-Hinton agar for sensitivity test, the height, and for that matter, the depth of the medium is very, very, very critical. And who can tell me for Muller-Hinton agar used for sensitivity testing, the medium that you put into the plate, the depth of it, who can tell me? Anybody who can tell me the depth of the agar in a plate for sensitivity testing? Of course, our media there will be Muller-Hinton. Who can tell me the depth of the medium, and for that matter, agar for the Muller-Hinton for sensitivity testing? If you know it, you kindly unmute and tell us. Oh, okay. All right, I thought somebody knew this. All right, if you pour the media into a plate for sensitivity testing, I'm specific because for sensitivity testing, there are requirements. For example, you cannot use any medium for your sensitivity testing except formula hinting. You cannot pour any depth of medium unless at a specific, and that is 4 millimeters. So take note of that. 4 millimeters. The depth of the medium in sensitivity testing, it is also regulated, and that is 4 millimeters. So the question is, how much of the medium should I pour to get my 4 millimeters? So you see that it comes back to a certain calculation where the diameter of the plate, for that matter, or the Petri dish, will come into play. That's why it is important to know the diameter of your Petri dish. So the standard Petri dish has a diameter of 90 millimeters. And so we have it at 90 by 15. And it is very common for examiner to ask, especially at diploma level, the dimensions of the standard Petri dish. Sometimes we also have some, which is 100, but that 100 is like some manufacturers are just trying to take a certain advantage and say that, oh, as for my plate, it is even bigger than the normal one that you are using. Okay, so they try to make this 100, but the standard size is 90 millimeters. Okay, right? You can have some as 100, but it is just superfluous, right? So, so in order, sometimes for examination purposes, even if they make this place 100, knowing that some manufacturers are able to make their Petri dish to have a diameter of 100 millimeters, they will intentionally change the height to, let's say, 20 millimeters. So that one should click you, yes, this is 90 by 15. But there's also 100. If they make 100 by 15, then it means the 100 by 15 too is not wrong, because there are some manufacturers that allow producing 100 by 15. But I've told you that irrespective of the diameter, whether it is 30 or 90 or 100 or 150, the height will always be what? 15. So take note, the height will always be 15. So if somebody writes 100 and makes the height 20, that one will give you, that one cannot be an answer. But if you have 90 by 15 and then 100 by 15, that one, it means that you have 2 answers. And normally there should be no 2 answers. And so the way to knock out the other one is to give you a wrong dimension for the height, which they will make as, let's say, 20. And then once you understand this one, you always have your way out. Good. So the dimensions of the standard Petri dish is 90 by 15 mm. All right. I've said that there are a lot of other type sizes. You can even include 150 millimeters diameter. Height will always be 15. Okay. All right. And take note, for purpose of observation, if you see 100 by 15, that could be correct. But since the examiners know that the height is the one that will be the difference, they will make that one 100 by, let's say, 20 or 18. Then that one makes that answer wrong. We also have what we call partition or compartmented Petri dishes. Partitioned or compartmented Petri dishes. I'm sure these days people are seeing some Petri dish that have been partitioned. Okay, so this example, she partitioned it into 2 rooms. This is normally called a biplate. So a biplate is a Petri dish which has been partitioned into 2 compartments or 2 rooms. All right. So this typical biplate. Then you can have some which have been partitioned into 3 rooms or 3 compartments, some into 4. These are new ones that are coming up. But the very common ones is the one which is divided into 2 rooms or 2 compartments, and we call it biplate. In fact, the true essence of it is to provide different media that help in bacteria growth and identification from a single plate. What it means is that if, let's say, you want to differentiate, let's say, Neisseria from Haemophilus. Now, you know that you have to plate the specimen on both chocolate and then blood agar, right? You need two plates, because knowing that Neisseria will grow on, the Haemophilus will grow on chocolate, but will not grow on blood agar, okay? And then, let me put my point clear. You want to differentiate between Neisseria and Haemophilus, all right? Now, Neisseria will grow on chocolate, will not grow on blood agar. Again, Haemophilus will also grow on the chocolate and not blood agar. So if at the end of the day, there is no growth on the blood agar section, but there's growth on the chocolate agar section, then it means that you know that no, this you rule out, let's say, Haemophilus. Okay, you found something like that. So in order to minimize the quantity of plates that you use, and then also to make things simpler, this is where the biplate system is coming on board. So that where sometimes you see people, they have a biplate, and if they are using for blood agar, they will pour blood agar here and here. If they are using for McConkey, they will pour McConkey here and here. It defeats the purpose for which the biplate concept was had been brought into being. All right. So you don't have to use the same media here and here. It defeats the purpose. So it means that you have to use two different media, all of which will supplement each other, and for that matter, help in identification. So if I put chocolate agar here, I should be able to put, let's say, blood agar here. So this is a blood agar, chocolate agar biplate. Or if I know that, once I plate wound, I'll plate it on McConkey and then blood agar. So instead of using two different plates, then I can use a biplate, and on that biplate, I'll pour McConkey here and I'll pour blood agar here, so that that sample can be plated on both blood agar and then McConkey on the same plate, so that it minimizes the number of plates that I have to use, and even if it has to be in the incubator, it's going to reduce the space, because now instead of using two different plates, I'm using one plate to serve two purposes, to serve the same purpose. So that's the concept of the biplate. All right, and so forth and so on. So I just want to introduce to you the concept of a standard Petri dish, the dimension, and also the concept of a biplate and how to use them. Even though there's a lot of people, even in my own lab here, sometimes that's what people do. If they have a biplate, they'll just use, if they are pouring McConkey, they'll pour some here and some here. It defeats the purpose. Okay, so you can rather pour McConkey one side and blood agar one side, and say that this is a blood agar McConkey biplate, or chocolate agar blood agar biplate, or chrome agar cleared biplate, something like that. Never the same media on the same biplate. It defeats the purpose. Very good. So we are adding a certain concept to what they will normally ask a question you about. They will normally want to ask whether you know the dimensions of the plate. That's all. I haven't seen this element of biplate and why do we use it as stuff like that. Now that we want to go beyond just examination, I'm just saying that once you understand all these things, anytime anybody asks you anything about the biplate and then the partition plates and so forth, I'm sure that you'll be able to understand it better and then also give very good answers to that. Right. Any question on this? Right. So let's go on to, we are going to look at some common stains in microbiology. Unfortunately, our time is up for now. I don't want us to rush. I want us to go slowly and understand every aspect of what we discuss. So these are some of the common stains that we'll be talking about tomorrow as we meet. Gram stain. I know you know a lot about gram stain, and this is still going to be the combo where you are combining all of us. So combine all of us will mean that you have to go to the lowest level as possible and then build on from there. So there are a lot of things that probably the MLS and the MLSD people think that's a waste of time, but I can assure you that you still need some of these things to enhance your basics. And then as you move on, you understand them better and better. And to also assure you that we do our best so that your investment in money, your investment in time will not be in vain. And also to assure you that we are not preparing you just for examination, we are preparing you beyond examination, and also try to, we know, I mean, we know the gaps that you see that you have benefit become difficult for you to explain to that person for him or her to understand. Okay, so it is important for you all as a I don't never were taught in school and you were never taught in your internship, but for which you may be questioned, or for which probably somebody would demand that you know about. So that is my first meeting information for you, but we are sure that you will learn and learn good. Thank you so much. Let's take the next 5-10 minutes to take questions and anything that you want to hear from me. Is it possible to unmute yourself, or you can unmute? Hello.
Hi, sir.
We can unmute.
Yeah.
we can
Okay,
unmute.
you can mute. Okay, right. All right. So let us know also your expectation. If what you seek to know is different from what I've told you, let us know that we are not here to learn, we are here for questions. Just let me hear your side, and then you see how we move on. Please feel free. Yes, sir.
Yeah, I just want to say thank you very much. Some of us have gone through the program all right, but we've not been exposed to the practical aspects that you are exposing us to. So we are grateful. We're happy that you are taking us from the basics, because some of us have gone through the theory, but
Hello. I think the person who was speaking has gone off.
hello.
Yes, sir.
Hello.
Yeah. Yes, sir.
Yeah. Good evening, sir.
Good evening.
Yeah, my name is Timothy. I'm so grateful for this presentation. My expectation was far overscored. I think you've done well, but I just want to make a submission on the presentation. If it should be very advisable where there's a need for you to do some calculation, and as in the normal saline and the inoculum, if you can use the pencil in doing the calculation, so that at least we can also be seeing it on the screen, since we are not using a chalkboard, that at least we can get actually what we are talking about.
Thank you very much. I think that there's also from the chat, Clote also wanted some more education on the calculation of the chloroform unit. I may probably have to ask somebody to take me through. Grandpa is still grandpa. I'm not too much computer literate, so to speak. And so the suggestion that you made, yes, I'll be happy to do that. I don't know whether I can do that unless I get one of my guys to help me to do that. I also love to do it. So if you wouldn't mind, let me see. I have one of my guys here. If you can come in to help us to take you through the calculation as you are suggesting. Is that okay?
Yeah, I'm okay.
Okay, thank you. So just give me some minutes and see if I can get somebody to help me. Yeah, online and not. They want me to take them through the app. Sorry, the first person I brought in also don't seem to know how to do it. So
okay, Grandpa.
Yes, sir.
So when you look down there, there's something down there called whiteboard.
Whiteboard.
Yes.
Is it
Should be
down
on the
or
right.
up? Me,
Okay,
my
it can
own
be at the top. Okay, so you look for whiteboards.
white.
Can you see it?
I'm seeing this icon with more, and then more. I'm seeing blah blah blah. I'm not seeing any white listening board there.
Are you using a laptop?
Yes, I'm using a laptop.
Yes, you should see it. After share screen,
After share screen, I
there's
have
pause or stop recording, reactions.
My own have an annotation, annotate.
Okay, apps.
And then I have, yes, apps.
Then
I should
whiteboard.
click. My own don't have whiteboard. After the apps, after the apps,
yes.
There's more.
Okay, so check for more.
Some three icons. And more, I have record on this computer, record to the cloud, reactions, disable annotations, hide names, hide floating meeting, share sound, optimize, blah, blah, meeting.
Okay, maybe later on we have to do this. It might disrupt the lecture. So
okay,
let's manage with this for now, and then afterwards we'll go through it.
Okay. So let me try to, those two calculations that people have challenged, let me try to see if I can still go back and then what on the chart, there's nothing like that there, I wish that. What about the I'm seeing the annotate. What does it mean?
Grandpa, try the annotate and let's see.
The annotate, when I click on it, I'm seeing mouse, select text, draw, stamp, eraser, format.
Can you see a pen there? Any object like a pen?
No, sir. I'm seeing mouse.
Pencil, pen, or eraser?
Yes, I'm seeing eraser.
Yeah, I've seen eraser. Then there should be a pen there. Design like a pen, something. So that is what you click on it. If you are using a mouse, so you click and hold the mouse and use it to do the drawing. I mean the writing. Sorry.
Writing too.
You don't need any external thing to connect. If you have a mouse, you can use the mouse. If you have, if you are using
I'm seeing a mouse
screen,
here too.
If you are using a touch screen, it will be better.
Touch screen.
Your laptop is not touch screen.
No, sir.
Okay, then you have to use the mouse. Use the mouse to do the writing.
I don't have mouse too.
Using the laptop pad will be difficult. Somebody has raised his hand. Let's see what the person wants to say.
Okay.
Oh, he's gone.
So tomorrow, God willing,
yes, we'll go through it.
By the time we go, we'll see something about it. So God willing, tomorrow, let me assure our participants that I'll get somebody to educate me on that, and then we will see how we can do the calculation. Because like I said over and over again, we should be able to go beyond examination. We should be able to do these things in our own labs. And for example, when we talk about a 5% saline, you don't necessarily even have to prepare 100 ml. But how do you prepare a small volume and yet get your 5% saline? You see, you'll be able to do that once I'm able to get the education on the drawings and what have you. Let me see. I'm seeing something here. Are you seeing something on the board? I'm just trying to see if, okay, so ladies and gentlemen, just pardon me for today. Can you hear me? Hello?
Yes, we
Grandpa, we
can
can hear you.
Yeah.
Yeah, we
So,
can hear you.
Yeah, I'm just saying that pardon me for today. Unfortunately, I'm not able to do the calculations as but I'll get myself educated, and then probably God willing tomorrow we do that. So all those calculations with respect to Saline, calculation with respect to the coliform unit, you'll go back to them tomorrow, God willing, and then you continue from there. Okay. All right. Any other question or suggestion?
Hello, Grandpa.
Yes, sir.
I suggest that the participants, come early so that we can start early. Today we started very late.
I think today a lot of people thought that we are going to start from 6 to 8. Okay, and then I have requested that timing is unsuitable for me. So that was also to me, that was also a factor. So I'm just saying that today. So I'm pleading with you that until time normalizes for me, I'll be doing 4 to 6.
Grandpa, what I've
yes,
heard
sir.
is that we should, log in early so that we can be admitted early.
Okay.
Some of us don't want to wait for 4 before we log in.
Okay.
If we start logging early, maybe by 15 minutes to 4.
Okay.
By 4,
the numbers will have. Okay. Okay. I think that the data is here. He has said you. So that they want, if you are starting at 4, they want you to open the meeting, let's say 3:45, so that the 15 minutes will be used for people to be admitted, so that by 4 exactly we can start.
That's fine.
So the 2 hours will be exactly 2 hours and not something less.
That's fine, Grandpa. Well noted.
All right. Ladies and gentlemen, thank you once again for having me, and please encourage your guys to join, because we are not going to share more slides. We are going to do more talking than slides. Okay, so if you think that even if you give the slides will be virtually empty. Okay, it is what you are going to take home that is very much important than anything. So encourage your guys to come. If you admit that by the time that we finish this whole program, you go to others, you know that what you have learned is even far more than the 4 or 6 years that you spent in school. Okay, you will have learned so many things that you never thought of when you were in school. Okay, so don't think about the money. Yes, the money, you are all young ones, you don't have money, but the benefit that you're going to get far outweighs the money. It far outweighs your time. It far outweighs the bundle that you are going to commit to this. I can assure you on that. Okay, so thank you once again. See you tomorrow and enjoy your night.
Thank you so much, Grandpa.
Thank you so much, Grandpa.
Thank you too. Bye-bye.